Okay, good morning, students. So, my name is K. Razu, Assistant Professor, Department of EEE, Svce. Today we are going to discuss about network theory concept, that is two-port networks. So, under lecture 3, I would like to deliver two-port network concepts under Prerana screen. So, the importance of these two-port networks for the GATE examination is having much more important. Why? Because we got uh, a compulsory question in the GATE examination regarding these two-port networks. So once we look after your GATE examination syllabus, which is going to be available for your examination is, so if you look at the syllabus under this electric circuits, you can find your two-port network concepts here. We have two-port network concepts here. So in this regarding, I would like to give a brief introduction to your two-port networks, how the examination questions are going to be asking in the examination we will discuss. So before going to two-port network problems, we have to understand what are the two-port networks, how many types of two-port networks are going to be available. So how we have to understand the two-port network concepts in real time. That is what we have to go and we have to understand. Right. We will proceed. So if you look at the screen, so two-port networks are going to be a wide variety of circuit. That means we have two port is there. So we have two ports for a simple circuit, for a network. For a network, we have two ports. So the two-port networks are going to be categorized into six possibilities. So by using six ways of conversion, we can get the two-port network parameters. So that parameters are open circuit impedance. The another name for open circuit impedance or characteristics is Z parameters. So another two-port network parameters are short circuit parameters. So in another name, it is also called admittance parameters. Or another name for these short circuit parameters is Y parameters. So we have discussed two parameters now. Another one is hybrid or H parameters. H stands for hybrid. You can pronounce it hybrid parameters or H parameters. So another dominant parameter is transmission or ABCD parameters. Another parameter is transmission or ABCD parameters. So just to go through the detailed discussion of these two-port network parameters in this class. So I just mentioned we have six possibilities, right? So among these six possibilities, we have Z parameters, Y parameters, and we have hybrid H parameters, and we have ABCD parameters. These are the main four parameters which are going to be generally used for a network. And this inverse hybrid parameters, another name for this inverse hybrid parameters is G parameters. This is number 5. And this inverse transmission or ABCD parameters. So this is analogous to your transmission parameters, and this inverse hybrid parameters is analogous to your hybrid parameters. So totally we have 6 parameters for our GATE examination regarding two-port networks. So we can't judge which parameter is going to be asked in the examination. Why? Because every parameter having sort of importance. So that means you have to understand all the parameter equations. Thereby, you can attempt the question in the examination. Let it be. Go for your detailed discussion of these parameters. So before going to two-port network parameters, what is mean by a port? That is very important. So as a beginner, you must be understand what is mean by a port. What is mean by a port? So a port of a network consists of two terminals, as we know that. So for any closed circuit, we require two terminals. One of the entry current and the port, another one is exit. So I said you that it is a two terminals. So one terminal is belongs to the entry point, another terminal is belongs to your exit point. So when you enter into a room, you must be leave. So whenever we are entering in, and we have to leave somewhere. So for our network also we have two terminals, one terminal for entry, other terminal for exit. So you can say in a electrical circuit manner, we required a port to enter our current. To enter current, we require a port, that is entry port, and to leave the current, we have another port that is called exit port. So the currents in the two terminals of port are equal. So whatever the current is entering into the port, the same current is going to be leaving the port. So the two currents, entering current and leaving current, is equal. So with respect to your two-port network. So port is going to be derived from a port, a French word. So try to understand what is meant by a port. So just look after our detailed syllabus, two-port networks. Two-port networks. That means I said, so we have two ports here, one port for entry, other port for exit. So the entire setup, the entire circuit is known as a two-port network. So on that ports, the entry port is known as input port. So we are going to derive a name for our entry port is input port, and we are going to name as our exit port as output port. So in our day-to-day life, we are going to discussing different types of circuits. So circuit having input, and we are getting some output from the circuit. So that is, the input is input port, and the output collected is output port. So the two-port networks is going to be having some variables here. So the two-port network consists of currents I1 and V1. These are the current and voltages at port 1. And obviously, our output port also having some voltage and current that name as V2 and I2. 2 stands for output port, 1 stands for input port. It is for significance purpose. So we are saying that V1 and I1 are the variable at port 1 and V2, I2 are the variables at port 2. So 2 stands for port 2, 1 stands for port 1. So the reference directions for your currents are obviously in this manner. Just look after this. So the entry port is I1 here, and the reference for your current is going to be available like this. So make sure the reference points are very important while solving the problems for your gate examination. So try to concentrate on the reference points of your currents. Yes, we will go next. So look at the introduction part of your two-port networks. So assume a linear time invariant elements. So we have to consider the linear time invariant elements may contain dependent sources but not independent sources. It may contain dependent sources. It may be voltage source and current sources. We need two linear equations in two port variables to characterize two port network. I already told you that. So we required two ports, right? We have two ports, right? So in order to solve these two port network parameters, you required two linear equations. So one linear equation subjected to port 1, other linear equation is subjected to port 2. Thereby, from these two linear equations, we can find out our two-port network parameters in order to examine the network. So in order to examine the network, we have different kinds of methods. So two-port network concept is one of the method to examine your circuit parameters. So in order to solve the two-port network problem, we required two linear equations, right? Just coming to forward, two can be taken as independent variables and the remaining two as dependent variables. So very, very important concept you need to be look after here. So in these linear equations, how you are going to be framing the linear equations means, so two can be taken as independent variables and the remaining two obviously dependent variables. So once you go through the circuit, you are going to be find out the circuit parameters, how they are going to be framed. The choice is just a matter of convenience for a given appliance. So for the given circuit, your choice. So how you are going to be taken as independent variables and dependent variables is as a choice of convenience. Based on the convenience, we can take the independent variables and dependent variables. But the procedure what you are adopting to examine the circuit is going to be very, very important. Right. Look forward. This is very important information what you are observing. So I said we have six parameters. We have six types of conversion in order to examine your circuit. So among the six, we get one. Number one is impedance parameters, that is called Z parameters. If you look at the Z parameters formation, just look at this one. We have V1 and I1. So V1 is equal to Z11 I1 plus Z12 I2. So try to be concentrate. V2 is equal to Z21 I1 plus Z22 I2. Z22 I2. This is the two-port network equations of your Z parameters. Z parameters. I already told you that we required two linear equations. The two linear equations are V1 and V2. V1 is subjected to just port 1 and 2. V2 is subjected to your port 2. While solving these two equations, you will get your Z parameters. From this two equations, what are the Z parameters? Can you imagine? Z11, Z12, Z21, Z22. These are the Z parameter values. You need to find these values. So again, we have short circuit parameters. We have short circuit parameters, or I1 is equal to Y11 V1 plus Y12 V2. Another equation which is subjected to port 2 is I2 is equal to Y21 V1 plus Y22 V2. So this is another set of equations subjected to short circuit parameters. So going forward, we have another one, hybrid or H parameters. The hybrid parameters are given by, the name itself, it is indicating hybrid. The combination of, if you look at the open circuit parameters and short circuit parameters, open circuit parameters are subjected to voltages and short circuit parameters are subjected to currents. But whereas your hybrid parameters are subjected to voltage and current, so there is some combination of voltage and current hybrid. So V1 is equal to H11 I1 plus H12 V2. I2 is equal to H21 I1 plus H22 V2. The combination of input voltage and the output current. So try to understand the difference of different kind of two-port equations. So while we taking hybrid parameter approach, we have to go through V1 and I1 as a two-port network equations. So just inverse of your hybrid parameters, I1 is equal to Z11. In the previously we said that H parameter contains H11, H12, H21, H22. But whereas coming to your inverse of hybrid is G11, G12, Z21, Z22. So just have a look at. So I1 is equal to Z11 V1 plus Z12 I2. V2 is equal to Z21 V1 plus Z22 I2. Just have a look at. And the next one is transmission parameters, another important parameters in order to in order to analyze so many different types of analysis. So if you look at the transmission lines, so the transmission line analysis is very easy when subjected to transmission parameters. The transmission parameters are given by, so V1 is equal to AV2 minus BI2. I1 is equal to CV2 minus DI2. So this is the transmission parameter equation. So if you go for this inverse of your transmission parameters, so V2 is equal to, so the indication is small a, small letters, so small alphabets, small a, b, c, d. So a V1 minus b I1, I2 is equal to c V1 minus d I. So these are the inverse transmission parameters. So while solving the different types of networks, so different kinds of approaches are going to be followed. So based on the convenience. So in the examination point of view, look at the question, and the question is asking for which parameters. So which parameter the question is framed. So try to understand and then you can proceed to solve that one. So going forward, so just have a complete two-port network equations here. So just to find out your Z, H, and the ABCD parameters and your admittance parameters. These four are very fundamental parameters. Uh, these these four are going to be a fundamental parameters. Number one here, admittance parameters. Number two here, and these hybrid parameters three here, and the number four here. And this remaining inverse of hybrid is going to be derived from here, and these transmission inverse transmission parameters are from here. So try to be look after the difference between inverse hybrid and your hybrid parameters and try to distinguish the difference between inverse transmission and your transmission parameters of ABCD. But the transmission parameters are denoted by capital letters of ABCD and these inverse transmission parameters are denoted by small letters. So moving forward, so So just generalized two-port network here. So we are seeing on the screen a two-port network consists of input voltage V1, input current I1, and the output port consists of output voltage V2 and the current of subjected to port 2 is I2. So by this regarding, what we are going to be understand means so every network, every electric circuit having some inputs and some outputs. So the inputs are going to be so when you apply a voltage, current obviously flow in the circuit. So obviously at the receiving end of your circuit, at the output of your circuit, so across the output we got some voltage that is V2 and the circuit also having some current at the output side that is called I2. So these are the two-port network variables V1 and I1 at input side, V2 and I2 at output side. So let's go for open circuit impedance or Z parameters. This is our first parameter network. We are going to be discussing about open circuit impedance or Z parameters. So we can name as in three ways: open circuit parameters, impedance parameters, and Z parameters. So in the examination point of view, try to be concentrate. So the examiner will give a question. So based on the question, he won't ask find the Z parameters. So he will ask you find Z12, find Z22, find Z11, find Z21. So in this way, the examiner is going to be asking you a particular parameter. So in order to find that particular parameter, so if the examiner asking you that, so if he asks find Z12, so you need to find Z12 value, how much it is going to be. So in order to find Z12, you have to be, keep in mind that what are the two-port network equations and which equation your Z12 is going to be available. So this is one of the way in order to solve your two-port networks easily in a short time. So try to understand, we have a Z12 here, we need to find Z12 value here. So your Z12 is going to be available in which equation? In port 1 or port 2? So look at these two equations. Look at these two equations. We have V1 and V2 here. So Z12 is going to be available in equation 1. Here. In this equation, your Z12 is going to be available. So in order to find Z12, what you need to be do. So I say that the Z parameters is a open circuit parameters or impedance parameters or Z parameters. So in order to find Z12, we have to take the necessary arrangements in the circuit. Thereby, you can easily find out your Z12. No need to find all the parameters in order to find Z12. So that is the time-waste process in the gate examination. So if you really have an idea about your two-port networks in the mind, so directly you can go for your equations. In that equations, Z12 is going to be available in each equation. Just based on that equation, we can easily find out your Z12 value. So moving forward, we will look after your Z12 value, how it is going to be find out. So jet parameters are going to be derived in a two sequence manner. In a two sequence manner. So that is when port 2 is open, you will find two parameters, and if you port 1 is open, you will find two parameters. So try to understand very important basic step we need to understand easily. Port 2 is open. Why? Because the jet parameters is also called open circuit parameters. By opening the circuit only, we can find the jet parameters. So that is a procedure what we frame in order to find the jet parameter. That is opening the circuit, opening the port. So while you open this port 2, you will get two parameters. So just mention here port 2 is open and your port 2 is open. So open circuit current is going to be 0, I2 is going to be 0. Here also I2 is going to be 0. So I2 0, I2 0. From your basic equation, if you put I2 is equal to 0, then the parameters which are going to be obtained are Z11, Z21. So these are the two Z parameters you will find when you open port 2. When you open port 2. So if you open port 2, you will get two parameters Z11 and Z21. So that is clear. So we have four parameters, right? So two parameters are going to be assumed now. So if you open port 1, so if you open port 1, what you are going to be achieve now? So if you open port 1, so this is port 1. So port 1 subjected to I1. If you open port 1, nothing but I1 is going to be 0. So if you open port 1, obviously the port 1 current is going to be 0, because in open circuit current is going to be 0, voltage will be available across the terminals, right? So that is very fundamental. So if you open port 1, I1 is equal to 0. If you open port 1 here, I1 is equal to 0. From these two values, you will get the Z parameters are Z12, Z22. See the way you are approaching the jet parameters in order to solve your jet parameter equations. So Z12, Z22, these are going to be achieved. So by opening port 1, so I think so far clear. Dear students, are you following, ma'am? Just let me confirm.
Yes, sir.
Yeah, thank you,
Yes, sir.
ma'am. So in this way, you are going to be solve your jet parameter equation. So while we taking a simple problem, so you can understand easily how the jet parameters are going to be achieved in a simple manner. But make sure that the destination. So the in the examination, if they ask Z22, you have to consider equation 2. If they ask find Z11, you have to consider equation 1. Why? Because your Z11 value is going to be available in the equation 1. So no need to find all the Z parameter equations. So as a academic wise, in the examination point of view, you are framing, determine the Z parameters. You are finding all Z11, Z12, Z21, Z22. But subjected to in the gate examination, like competitive examination, so not only for gate examination, for all the competitive examination, based on the question, you have to approach the answer. Based on the question only, you have to approach the answer. So that's why just keep in mind that your Z parameter equations, thereby you can achieve your equation, right? So a very important condition for jet parameters is, so when you are going to be said a condition of reciprocity is occur in the circuit means the value of Z12 is going to be equal to Z1. Very, very important relation for competitive examination. For a circuit is going to be said, the circuit is obtaining or following or something is going to be obeying reciprocity means the value of Z12 is equal to Z1. So these two values are going to be equal. Then you can say that the circuit is in reciprocity. The circuit is following reciprocity condition. In another manner, if you look at the circuit in another manner, what is another condition for reciprocity means? So it is one of the very important condition in order to solve, in order to understand your theorems also, network theorems. So I1 dash is equal to I2 dash. So dominant information, I1 dash is equal to I2 dash. So when you are going to be say I1 dash is equal to I2 dash means, so for a two-port network, we have taken a two-port network here. Just I'm taking some marker here. So it is a two-port network, figure A. So you are applying some voltage here, and the current is flowing through the circuit. So obviously, in the port 2, you got some current. That current name it as I2 dash. So for the sake of time, for the time being, so you are applying some voltage here, and the current I1 is flowing in port 1. This current and voltages are applied to this circuit, and obviously in the port 2, you got some current I2. You can say that name as I2 dash. So just make sure I2 dash. So same analogous is going to be applied here for the same port 2. You are applying some voltage here at port 2, and current is flowing through the circuit. Current is flowing through the circuit, and you got another current which is at port 1. For time being, it is a I1 dash. If this I1 dash and this I2 dash are going to be same, then you can say that the circuit is going to be following the reciprocity. This is the condition where you can study reciprocity theorem. While studying your fundamentals of electrical circuit, FEC subject, there you find your reciprocity theorem, right? That is, the same condition is also available or going to be achieved here in jet parameters also. When you apply a voltage at port 1, the response is noted down, that is I2 dash. When you apply a voltage at port 2, the response is I1 dash, which is obtained from port 1. If these two are going to be equal, then you can say that if these two values are going to be equal, then you can say that the circuit is obeying reciprocity condition. Very important. And we have another condition is symmetry. So in the examination point of view, certainly we have a point that so we can't judge which type of answer is going to be, which type of question is going to be asking for the examiner. So we have to be thorough in order to obtain a question. So a two-port network is said to be symmetrical if its ports can be interchanged without changing the port voltages and currents. So that is the definition for symmetry. So the definition of your symmetry is given by Z11 is equal to Z22. So if you obtain the values Z1 is equal to Z22, then you can say that the circuit is obeying symmetry. In examination, they will give you some circuit. So whether the circuit is following symmetry or not. That's it, simple. So for this question, you have to be find out Z12 value, Z22 value. If these two equations, if these two values are equal, then you can say that the circuit is following symmetrical. The circuit is obeying symmetry. Otherwise, the circuit is not obeying symmetry. So how you are going to be find out this Z11, Z22 means based on your two-port network equations. Based on your two-port network equations. So in a another manner, Z11 nothing but Z is going to be impedance. Z is equal to V by I. So 1 1 V1 by I1, 2 2 Z22 V2 by I2. So these are the conditions for your symmetry. These are the conditions for your symmetry. So look after this very important information. So while we solving the symmetry of any network, so you want to judge whether the circuit is following symmetry or not, you need to be take out Z11 value, Z22 value. If these two values are going to be equal, then you can say this way, the circuit is obeying symmetrical. Yeah. So very, I think it is one of the previous question paper I was taken here for the sake of convenience. So take a look after your circuit diagram. So we have a network consists of different kinds of resistors, and at the input side we have voltage V1 and I1. At the port 2 we have V2 and I2. So if you able to understand this simple question, then you can solve easily the kind of questions which are going to be available in the examination. So given the following circuit, determine the Z12 parameters. So try to look at the question. So they are asking about Z12 value. For the sake of simplicity, for the sake of understanding, I will discuss all the parameters, not an issue. But the examination, what I was taken in the previous question paper, this is one of the previous question paper. Z12 value they are asking. So how to find Z12 parameters? Can anybody tell me that Z12 is going to be available in equation 1 or equation 2?
Equation 1, sir.
Yes, thank you, ma'am. So Z12 is going to be available in the equation 1. The equation 1 is given by V1 is equal to Z11 I1 plus, thank you for your information, Z12 I2. So this equation is sufficient to answer your question. Why? Because our destination is Z12, our objective is Z12, so we need to find Z12 value. So no need to go for your V2. So another equation. So in this way you have to plan in the examination. In this way you have to plan your preparation. So based on your objective Z12. So for this time being, I am discussing all the Z parameters for the same circuit. So while solving Z12, you can say Z parameters, we have different kinds of approaches. So there is no strict rule in order to find these two-port network parameters. Somebody they applied mesh analysis, somebody applied node analysis, somebody simply applied these two-port equations to the circuit. So the way of convenience is very important while solving the questions. So there is no strict rule. So we need to follow this kind of only the method in order to find these parameters. No, that is not at all encourageable. So we can obtain different kinds of um, methods in order to solve this Z12 value, but ultimately we got the same answer, no issue, right? So we are taking in this class we are taking only the Z port two-port network parameters directly equations into consideration while solving this question, particular question. So just I'm taking a board here. Just yeah. So just I think my board is visible to you, right?
Yes, sir.
Yeah. Thank you.
Okay.
Look after your question. So we have a circuit. Obviously, port two, V2 and I2, and port one we have V1 here, and the current is I1 here. So the values they mentioned in the examination is 8 ohm resistor here and the 20 ohm resistor here, and 10 ohm resistor here, and 20 ohm resistor here. So our objective is in order to find Z12 value. This is our objective. So in order to find this Z12, already we have some information. We have, that is, V1 is equal to Z1 I1 plus Z12 I2. So V2 is equal to Z21 I1 plus Z22 I2. So I already told you that it is the impedance parameters. Impedance Z is equal to formula P by I. So as a time being, I already to mention that. So it is 1 1, nothing but. So already I told you that impedance nothing but V by I. 1 is there, 1 is there. So 1 1. Z 2 2. So this is V by I again. Why? Because it is an impedance. Z is equal to V by I. So we have 2 2 here. So 2 here and 2 here. So we have another. Look at. So very simple, very simple. We have another one. Z12 is equal to again V by I. One is there, one is there, two is there, two. V1 by I2. So Z21 again V by I. Why? Because it is an impedance. So two here, one here. V2 by I1. So these are the two parameters and these are the two parameters. So totally we have four parameters. So these four parameters is going to be recognized in this manner also. There is no problem for this remembering purpose. But these four parameters are going to be obtained from your circuit. We will see that in detail how you are going to be solve these four parameters. So I already told you that Z parameters are called open circuit parameters. So by opening the circuit only, we are going to solve our Z parameters. So for time being, we are finding out all the parameters. That is four parameters we are solving now. So have a look after your screen. So just I'm saying case two. So this is always practice purpose. So in the examination, you don't waste this much of time. So case 2 here it is. So case 2 nothing but port 2. Port 2 open circuit. Port 2 open circuit nothing but which value is going to be 0, Nana?
I2.
Yes.
Okay, sir.
Obviously I2 is equal to 0. Why? Because in open circuit current is going to be 0. So if current is going to be 0, what is the equations which we available now? V1 is equal to Z11, I1 is available, and I2 is going to be 0, right? So V2 is equal to Z21, I1 is going to be available. So this is one of the easiest method in order to solve the Z parameter. So from these two equations, you will get Z11, you will get Z21. Simply you will get these two values, two Z1 and Z21, Z2 Z parameter equations easily you can find. So rather than applying a mesh, rather than finding nodal analysis. So if you approach the mesh analysis, here you will get one, here you will get another one, here you will get another one. So this is taking some confusion if you skip any kind of notation plus and minus, then the entire answer is going to be having wrongly you will get. So in order to avoid that much of confusion, just we are following basic two-port network procedure only. This two-port network procedure only. So from this port 2 open, you will get two parameters that are Z11, Z21. Now your circuit is going to be redrawn port 2 open, right? So if you open the circuit, so if you open the circuit is redrawn. If you open the circuit is redrawn like this. V2 is available. Why? Because in open circuit, voltage is going to be available here. V1 plus minus. We have current in port 1, I1 obviously, but what is going to be 0 here is the port 2 current is going to be 0 here. I2 is equal to 0. So if I2 is equal to 0, 8 here, 20 here, 10 here, 20 here. So just to try to understand from these two port 2 open, you will get two parameters, right? You will get two parameters, right? One is Z11 and Z21. So for Z11, in order to solve Z11, so just to follow always equivalent resistance or impedance. One of the shortcut while solving Z11, you have to consider equivalent resistance or impedance from the circuit. So our circuit contains entirely resistors, that's why we have to take equivalent resistance. If our circuit contains some kind of inductance values and capacitance value, we have to take equivalent impedance value. So look after this equivalent resistance. By using equivalent resistance, how you are going to be find out Z11. So if you apply V1 is equal to the entire current which is available in the circuit is I1, and you can say that R equivalent value. Why? Because our entire circuit consists of only equivalent resistance. So that's why I just mentioned here is equivalent resistance. So from our circuit, R equivalent is equal to 8 ohm is in series with 20 in parallel with this 10 plus 20, 30. Very simple. In a simple step, we are obtaining the answer. So let it we concentrate again with another color. Just so I have 8 here. So 20 plus 30. This 20 ohm resistor is in parallel with this 30 ohm. So why? Because I2 is going to be 0 here. No current is flowing here. That's why 10 and 20 are in series. So 10 plus 20, 30, and in parallel with this 20. 8 plus 20 in parallel with this 30. If you find this value, you are going to be obtain this one as 20 ohm. So 8 plus 20 into 30 divided by 20 plus 30, you will get 20 ohm. So just to mention here, V1 is equal to I1 into 20. So the Z parameter equation V1 is equal to Z11 I1, right? So from this one V1 by I1. So V1 by I1, how can you mention this V1 by I1? Z11, that is equal to 20 ohm. See how easily you are obtaining without any mesh, without any nodal, just simply you are obtaining the answer Z11 value. So just make a note, Z11 is equal to 20 ohms. So from this circuit, other parameter what you are going to be achieved is Z Z21 value also. Z21 value also. So look at how to find Z21. So we need to find Z21, right? So in order to find Z21 again, so we have another one. V2 is equal to Z21 I1. So we need to find Z21, right? So Z21 for Z21. So how you are going to be find out Z21? So Z21 having V2 here. So this is very important. This is always a simple analysis while we solving the Z parameters. So Z21 is going to be subjected to V2 here. So if you able to write equation for V2, V2 is equal to V2 is equal to. So V2 is going to be available across this 20 ohm resistor, right? Across this 20 ohm. So V2 is equal to that resistance value into the current which is flowing in this 20 ohm resistor. That's simple. So if you are able to find the current which is flowing in this 20 ohm resistor, then you can find Z21 value easily. Yes, that much of simple thing you are going to be applied here. So how you are going to be find out the current which is flowing here in 20 ohm resistor? So in the circuit, the only current is available is I1. Why? Because I2 is going to be 0 here. Already I2 is going to be 0. So only the current which is available in the circuit is your I1. So I1 is common up to here. So I1 is going to be divided into two parts. I1 is going to be divided into two parts. So the name for the current which is flowing in this 20 ohm resistor is, you can say IY here, and you can name it is IX here. So V2 is equal to 20 IY. Is it okay?
Yes, sir.
Yes, V2 is equal to 20 into IY. The IY current is which is flowing in this 20 ohm resistor. Obviously, this IY is also flowing in this 10 ohm resistor, not a problem. But our V2 is subjected to this 20 ohm resistor. That's why across these two terminals, our 20 is there, 20 ohm resistor is there, 20 into IY. So you have to find your IY. So how to find IY value? Current division. So current division is total current into opposite resistance. Total current into opposite resistance. So
20.
yes, for this setup, 10 plus 20, what is the opposite resistance? Opposite resistance nothing but the current which is going to be flowing in the other part of resistor. So the total current is Ix plus Iy. Iy is going to be flowing in some way. Ix is flowing in some other way. The current which is flowing Ix in which resistors? That resistors are called opposite resistors. Very, very important for while solving the circuits. So we have total current Ix plus Iy. Iy is flowing in some resistors and Ix is flowing in some other resistors. The resistors which are having Ix current is called opposite resistors. So here opposite resistor is 20 by total current into opposite resistance by total resistance. Total resistance is 20 plus 10 plus 20, 50. So simply substitute this IY value here. So we have V2 is equal to, just go for this change of color. You can easily understand. So V2 is equal to 20 into IY is I1 into 20 divided by 50. See, Z21 is equal to V2 by I1 kada. Z21 is equal to V2 by I1. So we can name V2 by I1. So V2 here, I bring I1 here. So that is equal to 20 into 20 divided by 50.
8
So
ohms, sir.
your answer is 8 ohm. So how simply you are getting the answer is without applying any nodal, without any. So even simply you don't require the calculator also in order to solve this problem. So if you go for the mesh analysis, you will get two equations and you have to solve the two equations by using your calculator. So simply taking the time is more. So for time being, so if you are enough knowledge having current division and voltage division, simply the answer is going to be available within fraction of 1 minute. But for the sake of class only, we are taking this much time. But if you practice these methods for the circuits, you will simply within 1 minute you will get the answer. So we got Z11 and Z21 subjected to case 2, right? Go for your case 1. So for time being, I am discussing all the parameters. In the examination, we can't predict which parameter is going to be asking. So just I'm going for next two parameters for the same circuit, right? So the knowledge regarding this uh, method will give some confidence about your circuits. So just I'm erasing all the things. So these two equations over now. So we got another port is port 1. So just simply port 1 open. Why we are opening circuit? Because Z parameters are called open circuit parameters. By opening the circuit only, we are obtaining the values. So port 1 open circuit, nothing but I1 is equal to 0. So I1 is going to be 0. What happens in the circuit? That is very important. If current is going to be 0 for any of the circuit, obviously the resistor which is in series to that port is going to be 0, is not going to be considered. So for the circuit modified is, we have resistor here, we have 10 ohm resistor here, we have 20 ohm resistor here. It is port 2 plus minus, and here it is port 1, V1 is going to be available, but the current I1 is going to be 0. That is very important point you have to understand. So the current here is I1 is equal to 0, but I2 is will be live. I2 will be available. The resistors
Sir,
are 10 ohm, yes,
sir,
20, 20 here. Yes, Nana. Please ask.
sir, small doubt, sir.
Yes, you can ask me.
ఇప్పుడు I1 జీరో అయినప్పుడు అంటే కరెంట్ ఎప్పుడైనా జీరో అయినప్పుడు రెసిస్టెన్స్ వాల్యూ ఇన్ఫినిటీ ఉంటుంది కదా, అప్పుడు 8 months కూడా ఉండాలి కదా సార్?
Yes, that is what. So if current is I1 is equal to 0 here, that means the current which is flowing in the 8 ohm resistor is 0. So try to understand, the current
ఓకే.
which is flowing in 8 ohm resistor is 0. That means when any element which is present in the circuit having does not having any kind of excitation. So your current is excitation rho, right? So current is not flowing in your 8 ohm resistor. If the resistor is present in the circuit, that is not valid. Why? Because it is not participating in the conversion of your circuit. So while we following port 1 to port 2 or port 2 to port 1, 8 ohm resistor does not participating in any kind of activity. Why? Because the current in the 8 ohm resistor is 0. 8 ohm resistor is 0. That's why 8 ohm resistor is in series to your current I1. That's why this value is going to be eliminated. If 8 ohm resistor is in parallel with this port 1, then obviously 8 ohm resistor will be present. 8 ohm resistor will be present if your 8 ohm resistor is in parallel to port 1. So this is very important. Thank you for your doubt. So dear students, try to concentrate this point. So when you open a circuit, the resistor which is in series to that port is going to be not considered. Why? Because the current is not entering into that element. Why? Because that element is not participating in any activity of your circuit. If the element which is present in the circuit is in parallel with your port 1, if you open that port, that resistor will be live in the circuit. So you have to consider 8 ohm if it is there in parallel with your port 1. So thank you. Right. So from this port 1 open circuit, so we got I1 is equal to 0, right? So I1 is equal to 0, but go to your two equations which are there in your mind already. So your equations are, so your equations become I1 is equal to 0 now. Just have a look at. So V1 is equal to I1 is equal to 0. Z1 to I2. Yes. V2 is equal to Z2 to I2. So these are the two equations will be available now because of your port 1 open. So I already told you while finding Z22 and Z11, just always consider equivalent resistance or equivalent impedance. That is one of the very shortcut. So while solving Z22 value or Z22 value or Z11 value, while solving these two values, just consider equivalent resistance value. You will simply easily get the answer without any problem. So if your question is find the Z22, simply open the port 1 and find the equivalent resistance, you will get easily the answer. That much of simple. So I am taking Z22 first. Why? Because I already told you that. So while solving Z22 and Z11, you have to consider equivalent resistance or equivalent impedance. In my circuit, I have only the resistors, only the resistor. That's why I'm taking equivalent resistance. So R equivalent I am taking. So just go for V2 is equal to I2 into R equivalent, right? Why? Because we are concentrating on port 2. So V2 is equal to I2 into R equivalent. R equivalent is equal to R equivalent, you can say Z equivalent. Why? Because there is no impedance value, inductor value or capacitor value, just simply R equivalent. So R equivalent is equal to here. We have the resistors, we have the resistors 20 ohm in parallel with this 20 plus 10. 20 plus 10, 30. 20 in parallel with this 30, you will get 20 into 30 divided by 20 plus 30,
12
12,
ohms, sir.
12 ohm. Very good. Thank you. You get R equivalent is equal to 12 ohm. Just to simply go for your V2 is equal to I2 into R equivalent, that is 12. So Z nothing but V by I. So V by I nothing but V2 by I2. 2, 2. So we can name it as Z 2, 2. So 2 here, 2 here. So 2 will be here, 2 will be here. That is 12. See how much simple it is. No need to go for all the different activities which are going to be available. Simply you are getting the answer right. If your answer is, if your objective is Z22 in the examination, simply will get within 30 seconds this answer. So my sincere advice, dear students, don't go for mess and nodal. If you have some enough knowledge, if you have enough practice on this simple current division and voltage division, just simply apply and you will get answer. So just I'm going for your other parameters, other parameter. So the important point you need to be considered while solving this Z22 is or equivalent. So keep it in mind. So just sorry, I'm erasing that answer equation. So what are the other equation we have? So Z22 we got. So we have another answer. We have another parameter Z1 is equal to Z12. So actually the question is Z12 only they are asking. So Z12 is in nothing but Z12 nothing but we have to frame our equations in such a that V1 is equal to. So anybody V1 is equal to V1 is equal to 20 ohm resistor. So V1 is going to be available across this 20 ohm resistor. So V1 is equal to 20 ohm resistor into current. So which is flowing in this 20 ohm. Just I'm changing color. So the current which is flowing here in 20 ohm is IY. So the current which is flowing in 20 ohm is Ix. So your current I2 is going to divided into two parts. One is Ix plus Iy. But Iy is flowing in our 20 ohm resistor here. Here. So in this 20 ohm resistor, the current is Iy is flowing. So that's why V1 is equal to 20 into Iy. 20 into Iy. 20 into Iy. Very simple. So V1 is equal to 20 into Iy. So if you want to find Iy value is equal to total current. What is the total current available in the circuit is?
I2.
Yes, I2 into opposite resistance. So I already told you that. So we have a node here. The current is going to be divided here and here. Some of the current is flowing here, some of the current is flowing here. So the current which is flowing in opposite direction to us is Ix, that is flowing in 20 ohm resistor. That's why total current into opposite resistance divided by total resistance, 20 plus 10 plus 30. So 50. So as you mentioned, V1 is equal to 20 into Iy is I2 into 20 by 50. Substitute your Iy value simply that's it. So we already know that. So look at this equation. Z12 is equal to V1 by I2. See how logical it is. One is there, one is there, two is there, two is there. But it is a Z. Z nothing but voltage to current, ratio between voltage to current. Z is equal to V by I. 1 to 1 2. So V1 by I2. So already we got V1 here. Already we have I2 here. V1 by I2 is equal to 20 into 20 divided by 50. 20 into 20 by 50. How much you get? 8 ohm.
8.
So from this question, we have another relations also. we have other relations also. I think so. It is for, obeying some of the conditions. So what are the conditions we will be trace out by taking all the parameters into a matrix form. So in the examination, no need to mention all these matrix form, all those things. So just our destination is very important as we are running out of time. So just mention the Z parameters, what you obtained is so far. Z parameters obtained are, so Z12 is 8, Z22 is 12, and the next two parameters are
Z1120.
Z21 is 8, Z11 is 20. Thank you. So I think it is all ohms only. So what are the conditions it is going to be, this circuit is going to be obeying now? I think it is Z12 is equal to Z21.
Reciprocity, sir.
Yes. So reciprocity condition. No reciprocity theorem. So it is a reciprocity condition. So if the question is asking whether the circuit is following reciprocity or not, examine the circuit whether the following reciprocity or not. Yes, absolutely reciprocity is following. But coming to symmetry, is it obeying symmetry? No.
No,
So
sir.
20 not equal to 12. So symmetry is also not following. So in this way, you are going to be examining the circuit in a manner such that by looking after your equations, by looking after your equations only, we are solving the networks. This is one of the prominent method which I am following, which I am going to suggest you while practicing. So if you practice in this manner, you can simply obtain your equation. So in the next class, we would like to take again y parameter, h parameter, and again your ABCD parameters also for different circuits. So for this circuit, for time being as a basic, I have taken only the resistors in the circuit. If next class, we would like to take in place of your resistors, we will place some inductors and capacitors. So thereby, the full stuff of these two-port networks are going to be understand how you are going to be framing the equation and how you are going to be applying the equation, how you are going to be framing your parameters. We will see in the next slide. I think so. Tomorrow we have another session. At the same time, we will complete that H parameters and ABCD parameters and Y parameters. Why? Because so if you are enough knowledge having about your parameter equations, then you can easily apply the knowledge to different kind of circuits. That's why the basics are very important. The concept of these Prerana classes is to look after your basics. So once you very thoroughly knowledge having your basics, then you can apply this knowledge to your circuit. This is one of the previous question paper I have taken this circuit, but in the examination they are asking only for Z12 value only. But for time being, we have discussed all these three remaining three also. So in the next class, we will concentrate on impedance circuits. I think this circuit is only pure resistor circuit, right? So in the next class, we will discuss with respect to pure impedance network. So by taking three different problems for different networks, then you can easily understand how the networks are going to be simplified by using two-port network techniques. By using these simple techniques, we can achieve our answers. So,
Sir,
yes, Nana, please ask.
how to find image of the Z parameter, sir, by using
Image,
this?
image,
Yeah,
image, nothing but
the image parameters of Z.
image parameters of jet. You can say the jet parameters are going to be derived by using this kind of different circuits, right? So the image parameters of jet parameters are going to be derived from equivalent circuit of your jet parameters. So after finding the look at the screen. So after finding all these Z parameters, Z12, Z2, Z11, Z2, Z21, Z12, Z22, you are going to be framing equivalent circuit of your Z parameter model. By taking the equivalent parameter of your model, we are going to be find out the image parameters of Z parameters. So I think we are running out of time, right? So in the next class, by taking the image parameters of the same answer 28, 8, 12, and we are proceeding to your next image parameters of Z, and we are going to be discussing about your uh, H, Y, and your ABCD parameters. If it is time permits, we will take up the inverse parameters, image parameters of your net remaining remaining three parameters also. So if it is convenient, in the next class we will introduce transients also for time being. So transients is also having some importance on your circuits. So we will take up transients also in the next class. So for the knowledge what you get for the next class is the equivalent circuit of Z parameter model, just I mentioned, equivalent circuit of Z parameter model and equivalent circuit of Y parameter model. Of course, those are very simple. So from the equivalent circuit model, I will take up your image parameters of Z parameter. So in order to solve the different kind of parameters from the same circuit, we are going to be framing equivalent circuit. So obviously for this class, I'm not looking after your equivalent circuit. So for your answer, in order to address your answer, we will take up equivalent circuit of Z parameters and we'll proceed from equivalent circuit to image parameters of your network. Okay. So same time tomorrow we will meet again 9 a.m. sharply. So today we are engaging 20 minutes, right? So we will start early by tomorrow at 9 a.m. sharp. Why? Because we have to discuss three parameters along with image parameters for the sake of time being. Right?
Okay, sir.
Okay, Nana.